The building blocks of geometry. In this video, we're not going to be talking about polygons or three-dimensional objects. We're just going to be talking about the foundations of geometry. These 5 words here. A point. Well, think of the tip of a needle touching a piece of paper. It's an exact location. A line continues in both directions forever. I like to relate this to a number line in a classroom above a teacher's board, how it goes on forever into the positives and negatives. A plane. That's a flat surface. These are whiteboards in classrooms. These are the walls of the house. But a plane technically does go on forever in each one of the directions. A ray. This has a starting point and it continues in one direction forever. I like to relate this to a flashlight. Light starts from the flashlight and goes in one direction forever. A line segment. The word segment just means a piece, right, from one point to another. Think of your favorite segment in a movie. It might be halfway through the video, but what is your favorite segment, your favorite piece? And congruent, the exact same size and shape. Identical, if you will. Let's take a look at an example. When we're looking at 2 lines, well, we need to have a line that has arrows continuing in both ends forever. So if we look at the points I and H, well, there is a line that continues through those points forever in each direction. So what would this look like as an answer? Well, as an answer for lines, we need both of those points, I and H. But above it is a very specific code. We need to have a line with arrows in both directions to show that it continues through I and through H. Another line that we have would be F through H. So the 2 points that we would need to write down here would be FH or HF. It really does not matter. Either one would work. And what is HF? Well, we can tell what HF is by the code above it. A line is represented as a line that has arrows in both directions. Let's look at rays. Remember, a ray needs a starting point and it will continue in one direction forever. Now we said IF, line IF. But if we were to just start at point I and continue on through H in one direction, well, that's kind of like getting on a train in the middle of a city and going on in one direction. You can do that, no problem. So let's write down IH again. And what would the code look like above this? Well, we started at I and we continued through H. That code would point to the right. In fact, with rays, they always point to the right. If we were to start at point H and continue through I, well, that's going in a completely different direction. Rays can be flipped. You won't repeat yourself when you do that. So let's write down, instead of IH, let's write down HI. And how about 2 segments? Remember that segments are just the space between 2 points, your favorite piece of something. So we could talk about just the space between IH. And if we do it that way, we would have to write down IH once more. And what would the code look like above it? Well, we would use a line with no arrows above it. Another line that we could write here is the space between F and H. So we would write down FH, and the code above it would just be a line without arrows. Take a look at the 3 different ways to label. They all have 2 letters. You need 2 points, but a solid line with arrows on the ends represents lines. Rays will continue in one direction. Where does it start? What does it go through? And for segments, it's just a flat line, no arrows on top of them. How about a point? Well, any one of these points would work. We haven't looked at G yet. Let's pick point G. For point G, there is no code. There is no arrow that goes above it. So to label a point, we write down the word point, and then we can pick any point that we want. How about we choose the letter G? Point G. And how about a plane? Well, a plane is this flat surface that we're on. The whole thing is on one flat plane. Kind of like the screen that you're watching this on is a flat plane. Now it should continue in each direction forever, but how do we label this? Well, we write down the word plane. Once again, there is no code that goes above letters, and we need 3 different letters to label a plane. So we can pick any 3 you want. How about we choose randomly H, F, and G? Does not matter. And let's look at one last example. What if we had a line that had 3 points within it? Well, how many lines would we actually have? Let me show you a few little diagrams here. We could say, hey, there's a line going through points A and B. It continues in both directions forever. We could focus on B and C. There would be a line that goes through B and C. But what if we skip B and we just look at the far points, A and C? So there are actually 3 lines that we could write down here. So there are 3 lines in this one diagram. How many segments? Well, it's the space between A and B, not passing through it, but that's a segment. Also, the space between B and C would work. And third, we would have the space between A and C. So we also have 3 segments in this diagram. Now, how many rays do we have? If we started at A, we could continue through B. If we started at A, we could have continued through C. If we start at B, we could continue through C. So going to the right on this line, there are 3 different rays that we would have. But what if we started at C? We could start at C and go back through B. We could start at C and go back through A. Or we could start at C and pass back. Whoops, I apologize for that. We could start at B and go back through A. So these are 6 different rays that we would see in one diagram. Rays can be flipped because when we think about a flashlight, if we start at point A, the flashlight would be shining through B or C and continuing till it hits this wall over here. That is very different than starting at point C at one of these locations, shining a flashlight in the other direction and having the light hit the wall over here. So rays can be flipped, and they are the only item here that can be flipped.